Then, space, time, and our exact persistence within what we colloquially would call universe. Might it be connected by pi? Why? Who doesn't like a couple of pies? You all know what that means. We conjecture ahead. Oh, I hit the wrong. Oh my god! I almost ended the broadcast.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like "Ground Truth" or "Turtles All the Way Down," and so it seems as though there's one Ruliad. I don't think it rules them all, and it might be just hyper Rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-Rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. Yes, we're at a slightly different time. I've yet to have my nap nor cup of coffee. Why? Because I'm an old man. Perhaps not as old in this fleshy body as the realm of persistence, but let's just jump right. Okay, I know we throw out like a lot of math, these crazy. This is gonna be a lot easier. This is more like a choose your own adventure thing. I started to do some more precise calculations. I think just to kind of communicate the point, we'll just jump into it. So we go back to our friend Wikipedia again. Links to most all this stuff is in the doobly doo below down there. So hey Rick, thank you for joining, my friend. But the Planck units, yes, these are very important, at least within a lot of modern physics. And again, totally biased. The model of the minimal arena or the HF8 model. These are dimensional ingredients, and I think this is something worth exploring, just because it may help us get a little bit more of an intuition to what's going on. So basically, the claim is these are building blocks of reality. A lot of this, as we can see, have a numerical definitional of one, basically the speed of light, gravitational constant, because basically these are combining a whole bunch of different dimensions and everything right there. So that's pretty cool. So let's just jump right into it. Just because I was playing around, because a lot of times it's like, I remember Professor Carroll saying, well, you get a number, square it, cube it, take the square root, see what happens. If you feel it's valuable, and just explain, just seeing what's going on, getting a little bit more of an idea of what may be happening. Yes. Oh, Wikipedia. I don't often donate to places. I got no problem sending Wikipedia a few bucks here and there, just because I've used it so much. And then they send you all those ads, and then they'll send you it's totally worth it. At least a couple of bucks. But okay, we go to our friend over here. So our friend Wolfram Alpha. So what happens? We take the Planck time, which coincidentally, apparently to some folks, time seems to, it's a whole Zeno's paradox. It's like, what happens if you cut this in half? You cut this in half. You're like, can you just keep on cutting it in half forever? Apparently, no. That seems a little strange. Now, the minimal unit of time is about, what is it? 10 to the negative 44 seconds. Now, that's a really freaking short increment of time. Okay. So what happens when we do 1 over Planck time? All right, you get these numbers here. Okay. 1.8549. Again, you can just double click it. So basically 1.8 yada yada times 10 to the 43 per second. The unit conversion happens to come out to be in what we know as hertz. Hertz. It's like kind of like what the clocks on our computers and stuff run on. Maybe that's where they got it from. I don't know. Oh, if you look at frequency, that's the Planck frequency. Okay. And I just scroll down here. You see the basic unit of dimensions, time to the negative 1, because basically we're just having in our numerator 1, whatever that 1 may be, and dividing by that. So we got angular frequency. Oh, look, photon energy. Energy from energy, that's Planck's constant, times I believe V is frequency. Oh, I believe that's one of those equations that form the core of physics. Groovy. Let's click on that. Okay. So it gives us this interpretation. Okay. 7.6 yada yada times 10 to the 28 electron volts, because that's the measure of energy. Comes out to be about 12.29 gigajoules, or 10 to 1.2 yada yada times 10 to the 10 joules. You go down here and you're scrolling down. You're like, all right, let's go. Wow, 1/7 gram uranium, because Wolfram Alpha likes to. I was listening to one of the old Feynman lectures before, and he would always give these comparisons about different things. And I'm not saying that was one of the things going through Professor Wolfram's mind when he started the planning for such a crazy idea. He kept it secret from people because he was afraid people would talk him out of it. God bless the good professor. Okay, so dimensions there. Relativistic mass. Oh, 137 micrograms. You plug it in, you might be making a little difference there. 137. Does that have anything to do with anything that we might know about? I don't know. I don't know. Maybe. I haven't exploded enough yet. Wouldn't that just beat all? Okay. So we got that relativistic mass. Okay. That's groovy. But we don't even need that. We just look at the number there. 7.671 times 10 to the 28 electron volts. Okay. So we had time. This is 1/Planck time. We go over to our space coordinate, the Planck length. It's a minimal measure of length in our realm of persistence. At least that's what I hear some smart people say. Okay, the result is 6.1 yada yada times 10 to the 34 reciprocal meters. So meters to the negative what? What is that? A reciprocal meter? How does that even work? Apparently it is a thing. It's oh, that makes sense. Oh, thank you, Rick. I see. I've done some calculations before, and sometimes it's like, why am I off by 76 orders of magnitude? Oh wait, I swapped the Planck time on the Planck mass. One one is 10 to the 32, the other is 10 to the negative 44. Whoops! Now when I make that mistake, it clicks a little easier. But okay. So we continue to go down. Corresponding quantities. Oh, it does have a Hertz equivalent. That's cool. And then I noticed this here. Now again, this is the energy with the wave. Okay, so energy equals Planck's reduced constant, so we subtract the 2 pi out there, times c, which is speed of light there. And then we multiply that by this k, this frequency here. And that comes out to be this number. Okay, 1.2 yada yada times 10 to the 28 electron volt. 10 to the 28 electron, that sounds familiar. Where did I see this before? Oh, 1.6 times 10 to the 28. Well, I got my noggin a jog, and I'm like, what's the difference there? And just having done this for a while, and I'm just like, okay, that's the reduced Planck's constant. What happens if I click on this? Uh, uh, Hey, welcome, Jensen. Good to see you, my friend. We're doing a choose your own adventure while we're essentially attempting to maybe figure out what's going on within our realm of persistence using Wolfram Alpha and MacBook Pro that I may or may need a new one at. I still need to watch the developer conference to see if it's worth getting. Okay, so we take that number there. We click on it. Oh, look, that happens to seem to be an equivalence. The Planck energy. Groovy. That's cool. Go down here. Oh, what is this right here? 0.2 microgram. It's about 2.2 times 10 to the negative 8 kilograms. Oh, that coincidentally looks to be right around the Planck mass. Oh, very interesting. We continue. Let's go back. Okay, so we had those electron volts. So what happens? We were going to attempt to cast a computational spell. And by computational spell, I mean we're going to multiply it by a circle, 2 pi. Okay. We do that. And again, I'm sure plenty of folks know this and stuff already. Um, I'm just, and again, we're conjecturing here. We're conjecturing. I'm sure this is probably known. This is just I just got a little interested and I went down the Wolfram hole. It could be a totally fascinating place. Uh, yeah, well, Jensen, a lot of people feel that way. Um, Sometimes it can be kind of cool, but other times it can be a little lonely. It's okay. We're taking the fundamental ingredients of reality, essentially: time, space, charge, mass, and temperature. Coincidentally, you seem to be able to build our existence from those dimensions. Because dimensions, we usually think, okay, well, okay, we're gonna split a hole. We're gonna go into this multiverse. Not really that type of dimension. Um, Not necessarily even space is one of the dimensions. Yeah, you might be able to have like a 3 coordinates there, but you can characterize that as length. So we're literally just using the Planck constant. I literally just type in, what is it, like Planck time, just one, and just divide it by that math crazy number there. And you get these things. Okay. So multiply that by 2. Wait a second. 2.6. Excuse me. 7.6. It's 10 to the 28 electron volts. Doesn't that look a little familiar? Oh, okay. Yeah, the last digit is off right there. Yeah, full disclosure, but at least with a couple of digits there. Wait a second. So what you're saying is 1 over the fundamental unit of time, the minimal amount of time, according to many folks within science, happens to be this. And then when you do this is literally, go back one more, 1 over the Planck length. So the minimal unit to many smart people of length, and we do that, there's a connection between these two with a circle. That's very interesting. And again, that's why for the little thumbnail, I threw a couple of pies in there, because again, who doesn't like pie? But these things, oh my God, wow, I totally did the wrong thing. Thank you, Rick. Oh my God, I shared the tab. Wow. See, this is why we can't have that. Okay, let's go through this again. Okay, I apologize. Wow. That's because they changed the thing. And again, I normally do this later because I take a nap and have a cup of coffee by then. Okay, so wow. No wonder that made even less sense then. You're just showing us. That was like the time where I was showing like fizz fire ants and stuff like that. And I went to the Wikipedia article, but I was still showing like a murderous ant that her roommate Piper may not have had a terrible experience. Okay, let's do this once over. 1 over the Planck time. All right, Wolfram Alpha. Get this interpreted. Oh God, wow. That was absolutely terrifying. Thank you. I wouldn't have even noticed. I would just end the video and everyone like, what the heck is this dude talking about? They'll probably already do that. Okay, so we got these numbers here. 1 over the Planck time equals the Planck frequency. Comes out to be this unit right here. That's 7.6. 7 times 10 to 20. Basically, that's a bunch of energy. It's a photon energy if we were going to convert that. Okay, we take that. Cool. Go back over here. This is literally just 1 over the Planck length. Just 1 divided by Planck length. You literally just type that in right there. Get all these things here. And then you go down, you're like, oh, okay, the energy seems to be very close there. Oh, gigajoules to that. We click on that thingy. We'll throw it in brackets just in case it's going to give us any problems there, because we want to keep it separated. And then we multiply by 5. Probably didn't even need to do that, but that's okay. Okay. Oh, look. This number, 7.672 times 10 to the 20 electron volts. 7.671 times 10 to the 20 electron volts. Huh. It's the same amount of gigajoules. I just find it interesting that literally time and space seem to be joined by a circle. I mean, that really shouldn't be surprising now that you kind of think about it. It's like, well, Doesn't like Planck's constant, like the reduced Planck's constant is like that 1 point yada yada times 10 to the negative 34 or whatever joule seconds it is. And then Planck's constant itself, it's just that times 2 pi. I mean, I'm sure a lot of folks know about this, but this is something I guess it's fairly intuitive, I guess. But I look at that, I'm like, all right, that's really neat. Go to our friend, the Planck energy. 1 over Planck energy. Okay. Gives us 5.1 yada yada seconds squared kilogram meters. What the heck? 5.1 reciprocal joules units. Okay. So how folks did this back in the day, I have no idea. It's just literally Wolfram Alpha does this stuff for you. Gives you the basic unit dimensions right there. Okay, that's cool. So what happens? I click on these joules. What the heck does that do? I don't even know if I meant to do this. Did I? I don't know. We'll see. I put this together yesterday. Inverse energy. Oh, that's why I did it. Okay. Because if you take the Planck energy, you take the inverse of that. Okay. Let's get the ergs. Ergs. Again, I claim the erg is an underused unit. But basically, this crazy number, the negative 10 to the joules to the negative 1 reciprocal joules, corresponds to a quantity that comes up temperature, and that beta, 1 over kT, comes out to be 1.417 times 10 to the 32 kelvins. It's actually still calculating there too. It's thinking. What does that temperature correspond to? I think some folks in the audience already know this. Oh my god, my computer is lagging. Oh no. You can do it. I believe in you, Wolfram Alpha. That's my computer. I'm lagging. I think you can. I think you can. Oh, let's close some stuff. Oh wow. It's really thinking. Yeah, no, I mean most of these dimensions, I mean I mean it makes sense, but one of the interesting things is one of the things that Thad had told me was basically when he was basically yeah. Okay, here we go. This oh, they're not showing it. It's very interesting. Oh, temperature. So 1.417 times 10. Okay. So if we type in blank temper, sure. Yeah. I totally misspelled it. Comes out to be that. Oh, look. 0.4168 times 10 to the 32 Kelvin. The inverse of the Planck energy is temperature. The combinatorics here is absolutely fascinating. Hey, Fractal. Good to see you, my friend. It looks like Rick's putting the conversions down there in the chat for everybody. And again, I mean, this is stuff like I took modern physics for like I think like a week and a half in college. I needed to take like a more basic astronomy class or something for my degree or whatever. They were kind of overlapped, and these things happen. Did I understand what they're talking about? No. I was able to start to do some of the homework, uh, quantifying. I think must have actually been the energy of a particle moving like 0.9999 times the speed of light. Then all of a sudden, it's like something clicks. Like, oh, I understand calculus because it was interesting. So I stand by there. And so I just found interested that space and time seem to be connected by a circle. And that at one point had told me, he's like, oh, I was trying to find a geometric representation of the fine structure constant. And all of a sudden, it's like somebody sends him an equation, clears up the algebra, kind of like reformats the page, like, what lambda would I need? Oh, look, that's a number. The number has to come out to be the magnitude of the Planck mass. How very interesting. It seems like There might be something wrapping around the Planck mass boundary or something, or it's kind of going around it. That's a subtracted area of magnitude. It's, oh. Shh. But I'm just like, all right, pi, go to our friend Wolfram alpha hyperbolic vortex equation right here. Where does a circle show up? Oh, a circle happens to divide. Some may say that maybe that's more of a bulky component for something there. And again, I don't have no rigorous proofs. I'm just a dude on the internet just looking. I'm like, what could that interpretation be? Now, I did need to multiply 2 pi by that, so just something that's very interesting there. And 2.17, what was it? I think we had it. Where was it? It's corresponding. Okay, so for time, 137 micrograms. For space, so we go out. Oh, look, that's not quite. That does have some variance there. We do have some variance, and that was multiplied by the 2 pi. But if we go back, we scroll down, and the Planck energy, the 2.2 micrograms. Okay, and this is the space one. This is the one over the Planck length. Oh, 22 milligrams. Oh, excuse me, 0.022 milligrams. This would be the magnitude of the Planck mass. Wait a second, that 2.1 times 10 to the negative 2.1. What's going on here? I don't know, but I'm pretty sure there's some smart folks out there watching now or temporally in the future that may be able to help guide me. So, just wanted to put that out there. Thank you, Rick, for letting me know that I wasn't even sharing any of the right stuff. So we basically doubled the length of the video. Hey, you gotta get those watch hours somehow, even if they're by oops. But these things happen. Oh no, I'm not saying it's totally equivalent there, but we'll see. It's an exploration. It's a nifty little thing. It's interesting. Well, that's the thing. If you get people interested in stuff, maybe you get that one person that just they never looked at it. They just point this out. It's like, I never thought of that before. Because that happens to me all the time. So that's all I got for right now. Peace out, everybody. Take care of yourselves. It's a wacky and wild world out there, but I got some hope. I'm gonna take a nap because I'm an old man.